Welcome back, guys. So in this video, we are going to discuss about the binary search. Binary search is just nothing. It's just about the search and is the algorithm of the DS. It's just a technique of the search. It is a optimized technique to the search that isn't be used at. So we can use here also linear search, but the time complexity will be increased. That reason we don't use. So we will be discuss about the in this video also time complexity. So now just move on it. Okay. So here we go. So now, for the binary search, we have to sort. We have to sort our array. Okay. So I already sorted. That was the initial form, and after this sorted, that's I got. So just I have to make it here. So like suppose I want to search here. Maybe you can say 5. Okay. I want to search here 5. K will be 5. Okay. And like suppose I want to find here 5. So for 5, if I search here mid of this array, so what's gonna be mid? So if I plus this low plus high, and if I divide by 2, so this will be what? This will be mid, right? This will be mid. Okay. If I do that, so this will be gonna mid. And if I plus that 0 plus 4, which is what? Which is 2. Okay. So 6, have you seen it? 6 is a greater than to the no, mid is a greater than to the mid greater than to the k. K is that the value which you are searching about it. Okay. So mid is a greater than to the k. Here you can see. So this is sorted out, right? If it is greater than, and if it is mid is a greater than, then it means there can be possible we'll get the value of the k. Give me 1 second, guys. Just okay. So yeah, let's move ahead. So there can be, it is sorted. So if I go ahead after the 6, if I go ahead after the 6, so I'll be getting less than value of the 6, right? So give me 1 second, guys. There will be a disturbance. Just to me 1 second. Yeah. So now we can continue. So after there will be a sorted, and it is a greater than mid. Okay, mid now this, and it is a greater than the k. So this might be after this. We'll get less value because it is sorted after the 6. Okay. Sorry, before the 6. So there you can see there are there can be make a possible just 3, which is k will be equal to the mid, or k greater sorry, mid is greater than the to the k, and k is greater than the mid. So there can be make a possible just 3. So yes, we can there will make a possible possible condition. There can make be a just 3. So I'm just going to write on it here. So just have to remove it, and just I'm going to write separate, which will clear and which will clarify what's going here. And just I'm writing here. Okay, just have to do. Okay. So first thing is it can be equal mid can be equal to the k, or mid can be greater than to the k, or mid can be less than to the k. So there can be this condition can be happen because we have seen the first this condition already. So mid is greater than. So let's do it. So there can be this there can be this possible. So let's do it. So now just to the mid will be same, and so now let's start with initially. So I'm going to so if we do mid, so we'll get mid what 0 plus 4, which is by 2, which is also mid will be become what 2. Okay. Now mid is 2. So now mid is here. So this in among this 3 condition, so which condition this is like? So 6 is a greater than to the mid. Sorry, 6 is a greater than to the okay. Yes, 6 is a greater than to k. So if I go before the mid, so I'll get a lesser than value of 6, because we need a less value, and mid is a greater than. So if I just move my high, this is a low, and this is high. And if I just just move my just move my high. So the high, what we will become, we now to search, we not to just here sir, we not to search in this part, okay, not this part, because it is a greater than, it is a sorted. And if so we'll go further, we'll go further of the 6 mid, it means we'll go further of the mid, so we'll get more than value, more than, greater than the value of the k. So there will be no you say, there will be not making a sense to going beyond of the 6, beyond of the mid, because mid is already greater than of the k. So we need to search in this part. So for this, what we should make high, for we have to move the high. So give me one second, guys. Just do one second. I'm coming back. So here we go. So yeah, where I was. So yeah, so we need to search in this area, means beyond of the previous of the mid, just one step of the previous of the mid. Okay, so here we can write, where we can write h will be what, mid minus 1. Yeah, we can write this. Yeah, absolutely we can write this, because we need to search here. Mid what, mid is 2. Okay, mid is now 2. So if we do minus 1, so this will come here. So now h will become what, h will come here at position index of the 1. Okay, so now we have to just remove it. Okay, okay, and just move it. And after that, the h will here, h will be 1. Okay, so now if again we will come here in the mid, and if add the low plus high, so what's we'll get mid and divide by 2. So low plus high, low 0 and plus 1, because high is index of the 1, and divide by 2, which is what, which is 0 point something, right, 0.5, right. So this will be what, this will be 5. Okay, sorry, this will be, can be considered 5, sorry 0, I'm saying 5. So we will consider here 5. Okay, so now the mid will what become, mid will came here. So now this will see in among this condition. So k is equal to the mid, no, because mid is 4 and k is 5, so it is not equal. Mid is greater than the k, no, it's again 4. Mid is less than to the k, yes, because there you can see mid is 4 and k what, k is 5, so it is a less than now. So if it is less than, so that means we need to go beyond of the mid, right, because the mid is a less than, okay, and it is a sorted array. So we need to go of the mid just one step, because this step is smaller than of the k, right, this step is smaller of than of the k, of than of the than to k. So we need to go just one step of the mid. Okay, we need to go just one step of the mid. So because it is sorted, so we don't need to take a previous step from the mid. We can go further, because it is a less than of the k. So now we are so for going further, so which thing I have to move that, which is L, because we are not going to because the h I will be remain safe, but just we have to remove L, sorry, just we have to move L. So there what gonna make L, so we are taking just one step further to the mid. So L will what, L will what, L will mid plus 1. Okay, L will what, mid plus 1. So now just remove it, and h will be remain same, just L will be 1. Okay, so yeah, so now L will come again here, and we'll check L plus high, which is what, 2, and by 2 what, which is 1. So now what is mid, mid is 1, mid is what, mid is 1. So their mid is 1, so there will be a check among of this 3 condition. K is equal to mid, exactly, k is equal to mid, it means we get result, we get whatever we wanted to search. So just we can here return, we get the return mid. So yeah, so you can see it is true, we can return of the mid and we'll get mid. So what is the index of 1? Okay, so you can see here, guys, sorry for that, you can see here it is too easy in the way of the by the binary search. And if we do a linear search, so there can be, if we consider a worst case. So let's talk about the time complexity of this binary search. So just give me 1 second, guys, I'll be come back. Okay, oh sorry for this. Hi. Okay, just give me 1 second, Let me come back. Yeah, we can get back. Okay, so we get back. So where we was. So here you can see. So we are going to. We were going to see the time complexity of binary search and also linear search. Okay. So here you can see what was the length of the array. Can you tell me what was the length of the array? The length of the array should be 5. Okay. Yeah. Let's suppose so don't take the length of the array should be 5. Let's suppose there will be array. Okay. And there will be 1, 2, 3, 4, and 5, and so on. And so on. And there will be 64. 64 element means the no 63 element means the length of this 64. Okay. There will be 64 element. Okay, means the length of this array will be 64. So in the we have a scene here. We have a first we have a divide by 2 the sum of the low plus high. So there can be this possible. There can be, if we do in the first you can say in the first iteration, in the first time, yeah, you can say first time we had done like this 64 by 2. In the second iteration, I'm talking about the worst case. Means worst case means like suppose if we are searching about the 63, I'm talking about the worst case. Okay, so I'm talking about the worst case. So this will be what? This will be a second time, and this will be 64 by 2 into 2, right? Because we have done this before. So I'm talking about the worst. Worst means let's suppose we can say there will be run and time. Okay, so in the third times, this is gonna be run 2 into 2 into 2. Okay, so what is now? It is 2 into 2 into 2, which is what? 4 into 8. Okay, so 8. So now it is 8 and 4, and now it's going 6. Okay, now it's again it's in the fourth time again it's will call, because we are searching here 63 and 63 in the of the last of the array. So it is a worst case of the worst case of the array of the searching, because whenever we calculate time complexity means so we need to take a worst case, because worst case will give a perfect time complexity. So yes, so now if we do again, because it has already done, if I do again, okay, so yeah, so what is now sorry for that, I multiply one extra, sorry, so yeah, 2 which is what 16, it is total 16, and which will again will come 64 2 into 2, which is what 16 into 2 what 12, and 12 no, and what is 32. Okay, now it's become a 32. In the sixth time we'll check 6 2 into 2 into 2 into 2 and 2. Okay, so now this is a 32. So in the 32 we multiply by 2 4 and 4 and 2 into 6, which is what 64. So you can see so after this run, we'll get our result. We'll get searching what we have wanted to search. So we'll get after this must have. So after this means it become a 64, and it is the length of the array will be also 64. Now because we were searching by the worst case. Okay, means worst case. Okay, so now if we analyze here, so you can see that the multiply of the 2 will be k times. Okay, will be 2 k times. It can, like suppose there will be what 2 2 2 2, which is what 2 5, right? So it can be it is depend on length of the length of the array. So it can be 6, it can be 8, it can be anything. Okay, so so I'm considering this k, I'm considering this number or this power of the 2, so I'm considering this is k. Okay, not k, yeah, it will be k, because we are going to sing that so and here you can see eventually it will become what? It will become 1 because 64, and I multiplied here 1. This is I multiply this all of these factors, so it will become 4. So 64 1. So it is eventually and gradually will become what? 1 if I divide here. Okay. So here I can put here if I put, so eventually I'm talking about the worst case. Eventually it will become what? 1. Okay. So if I divide 64 by 64, or like the length of the that kind of stuff. So after that, I'm taking here 1. Okay, because if I divide 1 by 1, it's not gonna be effect because it will give me 1. So I'm multiplying here, cross multiply. We already done in the in this 6th and 7th class, this kind of stuff. So yeah, so now this is will become what 2k will be becomes 64. What 64 is n? Yes, I'm right here, no? 64 is n, and what the we are considering array length. Okay, the length of array. So n will become what? This is what. So if I do this will become that. Okay. So if I go here, and this will become 2, and equal to the n, because I multiply here this and this. Okay. So this is n, the array of the length, and this is a what? The number of times had for. Okay. So yeah. So now this is will be not a time complexity, because this we have to find k here. We have to find k here, then we'll get a time complexity of it, right? So if I take here log n both side, okay, if I take log n both side, 2k equal to n. If I take log n both side, take sorry log not no 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 log both side. I'm taking log, okay, this one, not log 10. I'm taking log, okay. So if I take log through here, and this will be what? Log n. Okay. So if I take both side log. So have you remembered this formula? This will be what? Log a will be b. This is the power of the a, b. So if we we simplify this, so it will be become what? B log a, right? This will become right, and this na. So you can see this is in this state, same state you can see here. So now just for now, just I'm going to simplify this. For that, if I simplify this, so what? So the power, the 2 of the power, which one is power? It is k. So I'm going to take here log 2 and log n, right? So you can see here, we also know about this, log a will be log a. What will become 1, right? We also know if we simplify this, so this will become what? 1. Okay. So here you can see this stays is same. This log 2 and the it is also 2. So what is now what is going to simplify? It's going to simplify k into 1 with its log n, and now it's got it simplified. It's got a simplified now. So here you can see k is log n. So this is a time complexity of binary search. Yeah, I was talking about the worst case, because I already told you the worst case will give you time complexity, a perfect time complexity of any any technique and or any algorithm or any data structure. Okay, so yeah, this is a time complexity of binary search. So you have to remember that, and you have to you can refer at this also video whenever you get stuck of the time complexity. So just I'm going to write here the time complexity will be of the binary search. I'm taking BC, means binary search, BS, sorry, not BC, sorry. And which will log n, log L. So yeah, you just have to remember it, not remember it, just you can do by your own, just simplify. So time complexity will be log n. Now if I talk about the linear search, if I talk about the linear search, so like suppose if this is array making and 2, 3, 4 and so on, and like suppose will be 20, and if I like suppose I want to search here, k will be what? 20, not k, take a s will be 20. So if I run here, so I need to go through all the element. So there I'm talking about the worst case, like suppose if I search here 61, so I need to it is not in the array, so I need to go through the all element. So you can see here, if I go here, I will go here, and all element I will traverse the all elements. See, so here you can see the time complexity will take, and you can see the time complexity will take, and there will take time complexity just log n, because they were just finding mid, and the mid was a reference of it, where I should move left side or a right side. Okay, left side or right side. Mid will tell you which side I have to move. So if I talk about the linear search, if I search in the this array will be 21, though in this array it is not in that 21. So it will run all the element, means all, you can say an element. So it will be time complexity will be n. So here you can see, because there is not referring, referring, and there is a not searching by the mid, it's searching by the all elements. So there will be time complexity will be n. So which is which is less than, which will take a less than time complexity, linear or search? Of course, binary search. Sorry, sir. Binary search. Of course, binary search will take less time, according to the time complexity. So linear, according to the time complexity, will take less time to the linear search. So yeah, this is a optimized way of the searching any element. So this is a optimized way searching of the element, and this. So yeah, this is not a optimized way. So, but just you have to remember one thing: in the binary search, you have to just you can implement binary algorithm on this sorted array. Okay, in the sorted element. So yeah, that's all from my side. And if you'll enjoy that this video, if you'll get more information, and if you'll get clarified by this video about the binary search, so I'll be glad for it. And thank you for watching my video, and we'll meet on the next video with a new topic. Okay. So yeah, that's all from my side, and bye guys. Welcome back guys.